Morning, everybody. It's Thursday, June 18th, around 9:18 in the morning, and I'm going to show you a live example of a shared neutral with two hots. Before I do that, I first want to give the official disclaimer. I'm not an electrical engineer. I'm not an electrician. I'm strictly a Google electrician, and I'm planning to do a basement finish, and so I'm trying to get a handle on the circuits that we have in the basement. And I've noticed a circuit that I'm going to be working with that actually has two hots and a shared neutral, and I wanted to verify that things were wired properly before I started doing anything with the circuit. I'll do another video later that explains about the circuits and what it is that we're worried about. But basically what you're worried about with this situation where you have a shared neutral is that you don't want the neutral wire to end up carrying more current than it was designed to hold. And in this case, we're talking about two 15 amp circuits. So we'd be working with the wire that's supposed to carry at most 15 amps. So I'm going to switch the camera to the front view and show you what circuits we're looking at. And then I will shoot another video to show you how I'm testing this to see that it seems like this is wired properly. All right, so I've got the dead front off the service panel, and yes, I do know right now that the panel is live. Okay, that's something that people would probably say, oh, you should never do this, and maybe you shouldn't. I'm not really going to be touching anything though, but this switch is still on. The service panel is live without the dead front on it, which means that there's a risk that you could touch something inside the service panel and get yourself a nasty shock. Because, like, for instance, there's the place that the circuit breaker would go, that the leg there is live. There's voltage going to that. So definitely do not want to be sticking your fingers in there, or you got a serious problem. You have a whole lot of current running through you. So what we're looking at here is there's this circuit and this circuit. And if you notice, there's a black wire coming out of this circuit breaker, and there's a red wire coming out of this circuit breaker. This one controls the basement lights, this one controls the furnace. And I have verified that if I were to turn these off, it in fact kills those circuits. I'm not going to be able to trace these two wires into the cable to show you for sure that they're sharing the neutral, because these two wires eventually make their way into, this was the original wiring in the service panel. There's somewhere in this mess here, and there's a neutral that's somewhere in there that's going to be shared somewhere up here. But I do know from looking in the basement, and we'll see that in the next video, that there is in fact the circuits that control the basement lights and the furnace, and there's the black and the red, and then you're going to see there's the one neutral and the one ground wire that's in here. So this is the setup we're looking at. And so the concern here is whether these two circuit breakers are on the same leg or not. And the way this is set up, it sure looks like they're on the same leg, because you would think that they would be adjacent if they were on opposite legs. So this looks disconcerting right now. Like, it seems like there's something wrong. But again, what you got to keep in mind is that our concern is whether, when we've got the current flowing through the two circuits, whether it's going to overload the shared neutral. So in other words, whether that current is going to be additive or it's going to be the difference between those two currents. So that's what we're going to check out when we go into the basement right now. And this is the two circuits that we're looking at.